Have you ever wondered what are the chances it will rain or how likely you are to be late for school? That's probability at work. Probability helps us understand how likely something is to happen. Probability is a number between 0 and 1. 0 means that the event is impossible and 1 means that the event is certain it will definitely happen. A number like 0.5 tells us that the event has a 50% chance of happening, like flipping a coin and getting hits. How do we calculate probability? There's a simple formula we can use here. Probability of an event is the number of favorable outcomes divided by total number of outcomes in the sample space. Let's break it down. Favorable outcomes are the outcome we want. Sample space are all the possible outcomes. For example, if our experiment is throwing a dice, if we want the probability of getting an even number, we first have to think of what are the favorable outcomes. In this case, even number of the dice are 2, 4, and 6. So we know there are 3 outcomes. And what are the total possible outcomes? It could be 1, 2, 3, 4, 5, or 6. 6 total outcomes. Now apply the formula, we get probability equal to 3 divided by 6 give you 0.5. So there's a 50% chance that you will roll an even number. Now let's talk about two special cases. A possible event. That is an event that can never happen. For example, if you roll a 7 on the center dice, that's not even possible. So the probability is 0. A certain event is an event that will always happen. For example, rolling a number between 1 and 6 on the center dice. Because these are the only numbers it has, so the probability is 1. Probability is not just used for dice and game. It's actually used in weather forecasts, sports, insurance, science, and even medicine. Understanding how likely something is helps us make better decisions in real life. Next time when you take a chance or make a guess, think about probability. It's your tools for thinking about uncertainty. Now that we understand the basis of probability, let's apply it to a common and fun example, a standard deck of playing cards. A standard deck has 52 cards in total, which include 4 suits, hearts, diamonds, clubs, and spades. Each suit has 13 cards, ace to 10, and then jack, queen, and king. So now let's look at this question. One card is randomly selected from a standard deck of 52 playing cards. What is the probability of selecting a queen? And what is the probability of selecting a red card? What is the probability of selecting a queen? Let's figure out the favorable outcome first. There are 4 queens in the deck. Queen of hearts, queen of clubs, queen of diamond, queen of spade. So the number of favorable outcomes is 4. The total number of cards in the deck is 52. Now using the formula, probability equal to the number of favorable outcomes divided by total number of outcomes in the sample space. The probability equal to 4 divided by 52 equal to 1 over 13. Now, what's the probability of selecting a red card? Let's first find the favorable outcomes. There are 4 suits in the poker card deck, and 2 of them are red, the hearts and the diamond. Each suit has 13 cards, so the total number of red cards equal to 13 hearts plus 13 diamonds, which equal to 26 red cards. Total number of red cards equal to 26, and total number of cards in the deck is 52. Therefore, the probability of selecting a red card equal to 26 divided by 52, which gives you 1 over 2. That means that you have 50% chance of picking a red card from the deck. At the same time, do you notice anything strange with the picture here? Look carefully. Notice anything with this wrong? Notice is that this deck of the card looks strange because it's generated by AI, and AI seems to have problem generating a nice deck of cards. Now that we know how to calculate probability, let's take some time to understand some basics and important properties of probability. These are basic rules that always apply no matter what kind of event we're looking at. Let's go through them one by one. First one is the bounded rule. The bounded rule says that the probability is always a number between 0 and 1. For instance, you can say that the probability it will rain is 0.6, and this is valid. But you cannot say that a probability of rain equal to 1.2, which is invalid. Remember that probability is always bounded by 0 and 1. In possible event, if something cannot happen, the probability is 0. You can write it as P probability of this event, E, equal to 0. For example, if I ask you to roll a 7 on the standard 6-sided dice, this is impossible because the dice only have numbers from 1 to 6. So the probability of rolling a 7 is 0. Certain event. If something is guaranteed to happen, its probability is 1. You can write it as probability of the event equal to 1. For example, if you roll a dice, the chance of you getting a number less than 7 is 100%, because every number on the dice, 1 to 6, is less than 7. The probability of something not happening is equal to 1 minus the probability of it happening. This is called the complement rule. You can write it as probability of the event prime equal to 1 minus probability of the event. For example, if the probability of winning a game is 0.3, then the probability of not winning the game equal to 1 minus 0.3 equal to 0.7. This rule is especially useful when it's easier to calculate the chance of something not happening and then subtracting from 1, and it's often tested in the exams. So please remember this complement rule. These four properties are the foundation of probability. We use them often as you solve more problems and learn more advanced ideas. Let's go through some interesting examples to test our understanding of the concept of probabilities. In example 1, a student says the probability of winning the game is 110%. What's wrong with this statement? Let's think about this. We know from the bounded rule that probability must always be between 0 and 1. A probability of 0 means the event is impossible. A probability of 1 means that the event is certain. Probability like 0.3 or 0.8 are valid because they are between 0 and 1. But 110% is the same as 1.1, which is greater than 1. That's not allowed in probability. So what's wrong with the student statement? Answer is that the probability cannot be more than 100%. So saying 110% is incorrect. Example 2, what is the probability of rolling a number less than 7 on the standard 6 dice? We look at all the possible outcomes. A standard dice have the number 1, 2, 3, 4, 5, 6. All of them are less than 7. So the number of favorable outcome equal to 6. Total number of outcome also equal to 6. And therefore the probability equal to 6 divided by 6 equal to 1. This means that it's a certain event, meaning that you will definitely roll a number less than 7 every single time. Now, lastly, we look at the last example. A bag contains 3 red balls and 2 blue balls. What is the probability of randomly picking a green ball from the bag? Let's count. Total number of balls equal to 3 red plus 2 blue equal to 5. Number of green balls equal to 0. So the probability equal to 0 divided by 5 gives you 0.